Okay, welcome back. Now I will demonstrate how to find the hot and cold topics with LDA clustering. Okay, so I'm now in RStudio again, and I'm in a file build optimal LDA model. So before we start analyzing our LDA model for the hot and cold topic, we try to build as good LDA model as we can. We again start out this by loading in our data. Happens the first lines, as you can see. But now, as we move to line 39, we split this to training set and test set. So we use 80% of the data for training and the rest will be used for testing. Testing how good is our model. So what follows is that we split here, and then we do the LDA clustering as we did it previously with the interactive clustering, but then we also test how good is the result. And what we try to do is we try to minimize the perplexity score, which is the variable that is outputted at line 64. Okay, so let's execute this once and see what kind of perplexity score we get. Now again, this takes a while as the clustering is built, and we get 1144. And our goal is to minimize this value. So if we do a quick theory jump to Wikipedia, we can see that the definition of perplexity says that it is a measure of how well a probability distribution or probability model, and we are actually building a probability model with our LDA clustering, predicts a sample. So we reserve the 80% for training, and then we try to predict the 20%. And a low perplexity indicates that probability distribution is good at predicting the sample. So we try to minimize this number. It means that we are better predictors when we get lower values. Okay, so line 63 in RStudio says, try playing with the number of topics, doc topic prior and topic word prior to see how to get better. So we want to get the better perplexity score. And the values I'm talking about are set in line 51. So this is the number of topics, this is the doc topic prior and topic word prior. Now we can test, would it be a better model if we have 20 topics instead of 10? Now this is quite simple. Now we only have to remember the value 1144, and we try to get lower value here. So we can try 20, for example. So we set that to 20, and we just rerun the lines from 51 to 64. And we actually get the better value. We get 1021. So it seems that having 20 topics is a better fit for the data. Okay, so you can try this in two ways. You can try to manually find the best combination of number of topics and these other parameters, or you can use a meta-heuristic search, a sort of a search engine that automatically boons these values for you. And we use the RPuckets DE Optim in this case. And what we do in lines 78 and 79 is that we set some boundaries for this optimization algorithm. For example, we set that the number of topics should be between 10 and 500. We set that the doc topic prior should be between 0 and 1, and that the topic word prior should be between 0 and 0.3. Now what the algorithm does, it simply tries to search for the best combination of all these parameters. Now, in order for this to work, we first have to evaluate the optimal LDA function at the end of this file. So we go at the end of this file, and we take from line 116 until the end, and we execute. Now we have this in the memory. Now we can start for the optimal search. So we simply execute line 85. Right. Okay, so I simply forgot to execute the function that loads in the library. So we load in the DE optim library, we set the boundaries, and as we now have the optimal LDA function in the memory, which you can also see in the global environment, here function optimal LDA is visible, and we can execute the line 85 and it should work correctly. And there is some warning that if this does not start printing any messages, it does not work correctly. And it's really picky, so you might want to restart at some point. But now we get messages and it tries, and we get information what is happening. So it's basically trying a set of different values. For example, the first attempt it made here, it attempted 187 topics, and having alpha, which is the doc topic prior, and beta, which is the topic word prior, for these values, and it got perplexity of 1178. And now it simply tries to search for different values. We can already see that we have found a lower number that we found with manual search, which is 998. And now this search will actually take a while. So for the demonstration purposes, I will simply stop it. Okay, so for the demo, I stopped the analysis, and I have actually previously done this. So I have found that 298 topics, and these priors are optimal values. And I have taken the time, ran the algorithm, and looked at the result. And now I simply apply these values that I have found by using the DE optim algorithm to create an optimal LDA model that I will analyze in the next file. Okay, and now I will simply execute lines 91 to 111 to create the optimal model. And at the end of this file, the model is also saved. And this generation takes a bit longer than the previous generation, as the convergence value, which was previously, we check for when to stop iterating. So the value was 0.01. Now here we have set the threshold lower, so it's 0.001. So the iteration will, so it will iterate longer. So it will perform a model that is more accurate. Okay, and so the file has stopped executing, and the file has been saved for further analysis.